What do you think is more interesting and impactful? Understanding how the universe works at a fundamental level, or understanding how the human mind works?
That's a great question. What is more impactful, understanding how the human mind works or understanding how the universe works? So this kind of comes back to the idea of what's more important, reductionism or emergent properties? What's more important, reducing down and understanding the universe at its most fundamental level? Or is what's more important, understanding the emergent properties inside of it? So it's a good question. I think the brain exists within the universe, which is a cheap answer, but and I've never seen these clips, so I'm just watching this live with you guys. I would say that the understanding the brain is how we're going to better understand the universe. I would say a cheap answer to that is understanding both. Move this over to here. There we go. Let's keep going.
Of course, this is a crazy, meaningless, unanswerable question in some sense, because they're both very interesting and there's no absolute scale of interestingness that we can rate them on. There's the glib answer that says the human brain is part of the universe, right? And therefore, understanding the universe is more fundamental than understanding the human brain.
But do you really believe?
I have to be careful there, because understanding the universe is more fundamental. Well, are emergent properties not fundamental? What does it mean by fundamental? Unless he means basic building blocks. But everything is the basic building block of the meta layer on top of it. So, Sean Carroll has a very specific point of view. So, I agree with him on a lot of things, but he's definitely a reductionist. He's a physicist. He spent his whole life studying physics. So it doesn't surprise me that that's what he's into.
They believe that once we understand the fundamental way the universe works at the particle level, the forces, we would be able to understand how the mind works?
No, certainly not. Right. We cannot understand how ice cream works just from understanding how particles work, right? So I'm a big believer in emergence. I'm a big believer that there are different ways of talking about the world beyond just the most fundamental microscopic one. When we talk about tables and chairs and planets and people, we're not talking the language of particle physics and cosmology. So, but understanding the universe, you didn't say.
I'm very surprised he went there. I'm very surprised that that's where he took that conversation. So he's kind of agreeing that these emergent data structures are what's important.
Just at the most fundamental level, right? Mm-hmm. So understanding the universe at all levels is part of that. I do think, to be a little bit more fair to the question.
Let's see. Well, I have some of the community in the chat. Does this sound all right? Does everything sound all right? I was doing some testing. And can you guys hear the video just fine? And I would, you need to, I have it set up to where if you turn your phone landscape, it'll probably be better. But okay, awesome. All right, let's keep going. So what's happening right now is Sean Carroll is talking with Lex Fridman. This is what I'm going to do. I'm going to do a few of these. I think like once a week. I need to watch videos anyways to stay up on things. So I figure why not watch the videos with the community? We can have a conversation. You guys can recommend videos, and we'll just grind it out for a couple of hours, learning about some of the science aspects of philosophy and religion while we all get a chance to kick it. So that's kind of what I'm doing right now. And Sean Carroll, the Lex Fridman opened with the question about what's more important, understanding the universe or understanding the brain? So that's kind of what he's going in about.
And there probably are general principles of complexity, biology, information processing, memory, knowledge, creativity that go beyond just the human brain, right? Mm-hmm. And maybe one could count understanding those as part of understanding the universe. The human brain, as far as we know, is the most complex thing in the universe. So it's certainly absurd to think that by understanding the fundamental laws of particle physics, you get any direct insight on how the brain works.
But then there's this step from the fundamentals of particle physics to information processing.
You can see he's learned a lot, though. You can see Sean Carroll, I've been following him for like a decade. And, a reductionist view is his viewpoint. He used to be, but now it seems like maybe he's caught on to some John Vervaeke emergent data structures. And, he's got caught in that position before, and now he knows better. So
processing, which a lot of physicists and philosophers maybe a little bit carelessly take when they talk about artificial intelligence. Do you think of the universe as a kind of a computational device?
No. To be like, the honest answer there is no. There's a sense in which the universe processes information, clearly. There's a sense in which the universe is like a computer, clearly. But in some sense, I think I tried to say this once on my blog and no one agreed with me, but the universe is more like a computation than a computer, because the universe happens once. A computer is a general purpose machine, right? That you can ask it different questions, even a pocket calculator, right? And it's set up to answer certain kinds of questions. And the universe isn't that. So information process.
Well, I'd be careful with that because, what he's saying is on a computer, you can ask it something, it runs the simulation, right? It runs, and then it gives you an answer. But how do we know we're not just in that that running, right? There's a question that was asked. The Big Bang, right? The Big Bang happened. That's the start of the computation, and it's still running. The simulation is still running to see how, with those input parameters, what's the end? That's what a computation is. And that's probably what he's about to get into.
Thing happens in the universe, but it's not what the universe is.
Because
and I know your MIT colleague Seth Lloyd feels very differently about this, right?
Well, you're thinking of the universe as a closed system.
I am.
So what makes a computer more like a PC, like a computing machine, is that there's a human that everyone's comes up to it and moves the mouse around.
Yeah.
So input
Gives it input.
And and that's why you're saying it's just a computation, a deterministic thing that's just unrolling. But the immense complexity of it is nevertheless like processing. There's a state, and then it changes with with rules. And there's a sense for a lot of people that if the human brain operates within that world, then it's simply just a small subset of that. And so there's no reason we can't build arbitrarily great intelligences.
Yeah.
Do you think of intelligence in this way?
Intelligence is tricky. I don't have a definition of it offhand. So I remember this panel discussion that I saw on YouTube. I wasn't there, but Seth Lloyd was on the panel, and so was Martin Rees, the famous astrophysicist. And Seth gave his shtick for why the universe is a computer, and he explained this. And Martin Rees said, "So what is not a computer?" And Seth was like, that's a good question. I'm not sure, because if you have a sufficiently broad definition of what a computer is, then everything is, right? And the simile or the analogy gains force when it excludes.
I think that's a great point. We have to, that's what we do in our community, right? It's about definitions. So what is a computer? Yes, we can say it's a computation, but what is a computer? What's the hardware? What's the software? Let's not just use these lofty ideas that are abstract where it's like, well, I'm right, but I don't have to give you any definitions. So Sean Carroll's making a very great argument here.
Something.
Oh, sorry, real quick. Persist. Yeah, what's happening, everybody? So what we're doing is we're just watching some videos, some science videos. I want recommendations. If you guys think there's a good... Now, I don't want it to be very long. I picked a bunch of clips, right? Just like 20 minutes. This one is a little bit longer. We're just going to watch a couple, talk about it. And so if you guys have recommendations, please put them down there. I have a queue right now, about 4 videos that I haven't seen. So I'm just watching them blind with you guys. Because like I said, I have to watch this stuff anyway. So I'm like, why not just go live and watch them with the community and have a conversation about it? So make sure you guys are in the comments, asking questions if you want. Make sure you're liking the live, share the live. We can get more people in here. And if this does well, I'll probably make it a weekly or bi-weekly thing, or twice a week, something like that. We'll see if it goes well. If I need to watch them, I'll probably just do it. It's just setting everything up takes a little bit of time. So I'm cutting in like 20 minutes, half hour of my study time to set stuff up, but no big deal if it's something that the community likes.
Things. Is the moon going around the Earth performing a computation? I can come up with definitions in which the answer is yes, but it's not a very useful computation. I think that it's absolutely helpful to think about the universe in certain situations, certain contexts, as an information processing device. I'm even guilty of writing a paper called Quantum Circuit Cosmology, where we modeled the whole universe as a quantum circuit.
As a circuit.
As a circuit, yeah. And
with qubits kind of
with
thing?
Qubits, basically, right, yeah. So, and qubits becoming more and more entangled. So, do we want to digress a little bit, because
Let's do it.
Kind of fun. So, here's a mystery about the universe that is so deep and profound that nobody talks about it. Space expands, right? And we talk about, in a certain region of space, a certain number of degrees of freedom, a certain number of ways that the quantum fields and the particles in that region can arrange themselves. That number of degrees of freedom in a region of space is arguably finite. We actually don't know how many there are, but there's a very good argument that says it's a finite number. So as the universe expands and space gets bigger, are there more degrees of freedom? If it's an infinite number, it doesn't really matter. Infinity times 2 is still infinity. But if it's a finite number, then there's more space, so there's more degrees of freedom. So where did they come from? That would mean the universe.
So when he's talking about degrees of freedom, I just want to make sure everybody understands what a degree of freedom is. A degree of freedom is a way in which something can move. So if something can move left and right, if something can move up and down, if something can move backwards and forwards, if something can move through time, right? These are different degrees of freedom in a classical sense. Then you have other degrees of freedom that happen on a quantum scale. But let's see if he gets into those. And I guess real quick, yes, Chris's crystals. I think maybe we will watch an AI video. I don't want to spend too much time pausing this because I know people want to, let's just watch the video. But I think that's a great point, and we should definitely talk about AI and how if AI is different than regular consciousness, and is it all just machine learning algorithms and whatnot. So
the universe is not a closed system. There's more degrees of freedom popping into existence. Mm-hmm. So what we suggested was that there are more degrees of freedom, and it's not that they're not there to start, but they're not entangled to start. So the universe that you and I know of, the 3 dimensions around us that we see, we said those are the entangled degrees of freedom making up space-time. And as the universe expands, there are a whole bunch of qubits in their zero state that become entangled with the rest of space-time through the action of these quantum circuits.
So what does it mean that there's now more degrees of freedom as they become more entangled?
Yeah. So
as the universe expands.
That's right. So there's more and more degrees of freedom that are entangled, that are playing the role of part of the entangled space-time structure. So the underlying philosophy is that space-time itself arises from the entanglement of some fundamental quantum degrees of freedom.
So he mentioned qubits, and I just want to make sure everybody knows what qubits are. So we know what bits are. Bits are ones and zeros. That's binary coding. And from ones and zeros, we can get to hexadecimals, which then we can get to regular ASCII, which is just like, your alphanumeric letters. But qubits, on the other hand, are 1 and 0, 1 or 0, right? It's there's 4 states as opposed to 1. So it's right. It's binary. It's a 1 or it's a 0. But when you get into qubits, now you have these entangled states where you don't know what the bit is. You don't know what the bits are. It could be a 1 and it could be a 0, or it could be it could be a 1 and it could be a 0, or it could be a 0 and it could be a 1. You get these mixed states because the 1 and 0 are entangled. The representation of a 0 bit and a 1 bit inside of a quantum computer or a qubit, which is what a quantum computer uses, a qubit, has these superpositions of 1s and 0s. Sarah, what's happening here is essentially we're just watching. I have to watch these videos anyways. I've never watched these. So to stay up on my science, I'm generally just watching these on my own. And I decided why not watch them with the community? And, we could have conversations. I want you guys to pick videos if there's specific videos you want us to watch. So this is going to be a thing I'm probably going to do weekly, maybe twice a week, depending on how well it does. If people enjoy it and we're hanging out and we're watching videos and we're having good conversation, then I'll probably continue to do it. It just takes a little bit of time to set everything up. So it just depends on if it's worth it or not. That's all. So here we go.
Wow. Okay. So at which point is most of the entanglement happening? Are we talking about close to the Big Bang? Or are we talking about throughout the?
Sorry, one more thing, guys. If you guys see me looking over here like this, it's because I'm looking over at the screen to see where the chat is. So I've got chat over here, and I'm trying to watch the video over here as well. I tried to do it all on one window, and it just looked crazy. So if you guys see me looking over here, it's just because I'm trying to see what you guys are talking about. All right.
The time of the
Throughout
life
history.
of the
Yeah. So the idea is that at the Big Bang, almost all the degrees of freedom that the universe could have were there, but they were unentangled with anything else. And that's a reflection of the fact that the Big Bang had a low entropy. It was a very simple, very small place. And
Sorry, so low entropy, right? So what he's saying is all these degrees of freedom existed in what? A state of potentia and potentiality. They were all there, but they weren't entangled. They weren't interacting with each other. So he's kind of hinting at this, capacitated absolute state that was there at the beginning of the Big Bang. This is why philosophy is so important with physics, because when you get to the end of the understanding of what we know in physics, if you don't have that meta layer to try to make any kind of logical deduction of what's happening, well, then what? Well, you're stuck. You're stuck with the next person that's actually thinking about it to help you as an experimentalist. He's literally talking about the same thing that philosophers talk about when they're talking about an absolute state, a potential, the idea, the superposition, all these things. So that's what he's talking about right now.
as space expands, more and more degrees of freedom become entangled with the rest of the world.
Well, I have to ask John Carroll, what do you think of the thought experiment from Nick Bostrom that we're living in a simulation? So I think, let me contextualize that a little bit more. I think people don't actually take this thought experiment. I think it's quite interesting. It's not very useful, but it's quite interesting. From the perspective of AI, a lot of the learning that can be done usually happens in simulation from artificial examples. And so it's a constructive question to ask, how difficult is our real world to simulate?
Right.
Which is kind of a dual part of, if we're living in a simulation and somebody built that simulation, how hard, if you were to try to do it yourself, how hard would it be?
So obviously we could be living in a simulation. If you just want the physical possibility, then I completely agree that it's physically possible. I don't think that we actually are. So take this one piece of data into consideration. You know, we live in a big universe. Okay. There's 2 trillion galaxies in our observable universe with 200 billion stars in each galaxy.
So I think what he's about to get into, and let's see if my intuition is correct, because I haven't seen these, but I've heard this argument before, and I got a little glimpse. So this is why I think it's where he's going, because he started talking about SLAYS. And it's the main argument against simulation theory is this idea that you would need an infinite processor. So because we all know, Sean, if you don't know, Sean Carroll believes in the Everettian interpretation of quantum mechanics. The Everettian interpretation of quantum mechanics is the many worlds interpretation, is probably how most of you guys have heard it. And you've seen it if you've watched any kind of, right, all the comic books and Marvel movies, and everything is kind of tapped into this idea of different timelines. And I think that's where he's about to go, into this infinite aspect of reality that would create a paradox, because you would need an infinite processor to process all this information. But let's see. What do you guys think?
Each galaxy, etc. It would seem to be a waste of resources to have a universe that big going on just to do a simulation. So in other words, I want to be a good Bayesian. I want to ask, under this hypothesis, what do I expect to see? So the first thing I would say is I wouldn't expect to see a universe that was that big. Okay. The second thing is I wouldn't expect the resolution of the universe to be as good as it is. So it's always possible that if our superhuman simulators only have finite resources, that they don't render the entire universe, right? That the part that is out there, the 2 trillion galaxies, isn't actually being simulated fully. Okay. But then the obvious extrapolation of that is that only I am being simulated fully. Like the rest of you are just non-player characters, right? Yeah. I'm the only thing that is real. The rest of you are just chatbots. Beyond this wall, I see the wall, but there is literally nothing on the other side of the wall. That is sort of the Bayesian prediction. That's what it would be like to do an efficient simulation of me. So like none of that seems quite realistic. I don't see, I hear the argument that it's just possible and easy to simulate lots of things. I don't see any evidence from what we know about our universe that we look like a simulated universe. Now, maybe you can say, well, we don't know what it would look like, but that's just abandoning your Bayesian responsibilities. Like your job is to say, under this theory, here's what you would expect to see.
Yeah, so certainly if you think about simulation as a thing that's like a video game where only a small subset is being rendered. But say all the laws of physics, the entire closed system of the quote unquote universe, it had a creator.
Yeah, it's always possible.
Right. So that's not useful to think about when you're thinking about physics. The way Nick Bostrom phrases it, if it's possible to simulate a universe, eventually we will do it.
Right.
You can use that, by the way, for a lot of things.
Well, yeah.
But I guess.
So to me here though, it's like, well, we're kind of already we're already simulating things. Video games and VR. Now, granted, there are limitations to these simulations, but you have an avatar in which you're controlling inside of a simulation. And if we could scale that up, there's no reason. I mean, look what Meta's working on. Meta's working on this entire world you can live in with different advertising, and you create your own body, and with Neuralink, and we're on the edge of technology that makes me feel like we will have the ability to live inside of a virtual reality with any avatar and have magical powers and yada, yada, yada very soon. And then you'll just need AI to render the world around you. So you can, depending on how you move through that world. Now that's going to be a different conversation, because I've seen like the treadmill, like the Omni treadmill that you kind of stand on and you can walk in any direction, and there's like a harness. It could be something that when you think that you're moving, you start moving. So who knows how all the details are going to play out, but I don't really like that argument.
I guess the question is, how hard is it to create a universe?
I wrote a little blog post about this, and maybe I'm missing something, but there's an argument that says not only that it might be possible to simulate a universe, but probably if you imagine that you actually attribute consciousness and agency to the little things that we're simulating, to our little artificial beings, there's probably a lot more of them than there are ordinary organic beings.
So Sarah said, why don't you like that argument? And Alien T said, how would it materialize? So I don't like the argument that creating a simulation is out of reach, which is what it felt like Sean Carroll was saying, because he doesn't like the idea that we live in a simulation, because it's like he's saying it's out of reach, it's too far. And he's trying to shelter his mind, and this is something that you see in academia, and it's a very important tool. You have to be able to shelter your scientific mind and say, well, I'll go so far, right? I'll step 2 steps outside of experimental to get to a place where I can try to pull that information back into reality. But it seems like simulation might be too far for him. So I don't like it, because I think we're already on a micro level making simulation. And Alien T said, how would it materialize? It would be the same way. It'd be virtual, but virtual, our perception it depends. Like you start to think about virtual and what does it mean to be virtual? And, the fact that I can feel something is a sensation, see something is a sensation. It's chemical reactions happening. So it's as virtual as if, you put on a headset. You can see this. If you put on a VR headset, I've seen videos of this where it's like you're walking across the Grand Canyon and you're like on a little board. Has anybody seen that? And the people, if they lose their balance and they start to fall, they really think they're falling, right? They get scared and they ball up or they yell, because it's tricking the senses that are already there, because the senses is just an input. So for me, it's like, well, we're kind of like, I don't see a difference between our perception and virtual reality. So that's how we would materialize it. Yes, we would still need a body, right? We'd still need some sort of a host for now, but I could see that even changing. I mean, once we understand consciousness, could we transfer self-awareness temporarily to another object, especially with the help of things like Neuralink or a robot that moves. When you think about moving your arm, it moves, right? We're already doing that with people that have prosthetic limbs. Right? We're getting to the point to where it's the nerve. If the nerves fire, they can still kind of move if they think about moving. So it's similar to that. It's just now, instead of it being attached to your body, you'd have to find a way to send it to another one. Let's see. That is where the body used. Here, let's keep going.
Beings in the universe, or there will be in the future, right? So there's an argument that not only is being a simulation possible, it's probable, because in the space of all living consciousnesses, most of them are being simulated, right? Most of them are not at the top level. I think that argument must be wrong, because it follows from that argument that, if we're simulated, but we can also simulate other things, well, but if we can simulate other things, they can simulate other things, right? If we give them enough power and resolution. And ultimately, we'll reach a bottom, because the laws of physics in our universe have a bottom. We're made of atoms and so forth. So there will be the cheapest possible simulations. And if you believe the original argument, you should conclude that we should be in the cheapest possible simulation, because that's where most people are. But we don't look like that. It doesn't look at all like we're at the edge of resolution, that we're 16-bit, things. But it seems much easier to make much lower level things than we are. So, and also I question the whole approach to the anthropic principle that says we are typical observers in the universe. I think that that's not actually, I think that there's a lot of selection that we can do that we're typical within things we already know, but not typical within all the universe.
So do you think there is intelligent life, however you would like to define intelligent life, out there in the universe?
My guess is that there is not intelligent life in the observable universe other than us.
Wow, what that is just, what a terrible, I got to see what he has to say about this, but what? Is he familiar with the Drake equation? In the observable universe, he doesn't believe that there is any intelligible life? Wow. But he believes in a multiverse. So that's what's crazy. And I got to know his difference between where does his differences lie with Everettian interpretation? Because the Everettian interpretation says that there are other versions of us within this universe. So, right, level 1 is other versions of us, other Goldilocks zones where people actually look very similar to us, right? There's another Trent running around, except maybe he decided not to stream today, right? That was not a part of his destiny was to stream today. So I very curious why he would say that. Maybe because he's going to get into the multiverse and say, well, not in our observable universe, but in the multiverse.
Simply on the basis of the fact that the likely number of other intelligent species in the observable universe, there's two likely numbers, 0 or billions. And if there had been billions, we would have noticed already.
Not necessarily, because it's infinite.
For there to be literally like a small number, like, Star Trek, there's, a dozen intelligent civilizations in our galaxy.
Here's the issue with that argument is you can't say, oh, well, because we haven't, first off, how do you know we haven't? Jean Carroll, do you know that no one on Earth has interacted with any other intelligent life? What, because it hasn't shown itself or taken over? It's just, that's a ridiculous argument to think that he would know because he's Sean Carroll. And of course, if there were aliens, they would tell me because I'm Sean Carroll. I mean, I'm just being facetious, but so that's not a good argument at all. And to say the other side, well, it's not like we would be running into it all the time because like he just said, the observable universe, there's trillions and trillions, right? We've got trillions of planets inside of trillions of galaxies. So why would you think that for the blip we've been here, and you got to think, this is just recorded history. So we're talking a couple hundred years. Okay, let's say a couple, let's just say 2,000 years. For 2,000 years, within billions of years. Oh, because we haven't ran into him. I mean, it's just, I'm very surprised at that answer. What do you guys think?
Galaxy, but not a billion? That's weird. That's sort of bizarre to me. It's easy for me to imagine that there are 0 others because there's just a big bottleneck to making multicellular life or technological life or whatever. It's very hard for me to imagine that there's a whole bunch out there that have somehow remained hidden from us.
The question I'd like to ask is, what would intelligent life look like? What I mean by that question and where it's going is, what if intelligent life is just fundamental. It's in some very big ways different than the one that has on Earth. That there's all kinds of intelligent life that operates at different scales of both size and temporal.
Right. That's a great possibility, because I think we should be humble about what intelligence is, what life is. We don't even agree on what life is, much less what intelligent life is, right? So that's an argument for humility, saying there could be intelligent life of a very different character, right? Like you could imagine.
Yeah, Vince of York. That's a great point. Sean's under the illusion that his sense perceptions are showing him an accurate depiction of reality. So yes, not only, and we go over this argument in the book inside of, I think this is in Substance and Structure. We go from the Drake equation. First, we start at particles and CERN and understanding particles and how they interact. And then we kind of go to different, there's a huge universe and there's life within that universe. So, the Drake equation shows us that there's going to be intelligibility, especially inside of an infinite universe. Even if it's not infinite, even if it's trillions and trillions and trillions, there are, I forget what the number is. It was somewhere in the hundreds of thousands or millions of advanced life forms. And then, but this is over the course of time, right? 4 billion years or whatever. So then we go to, and what about the particles we don't interact with, and trying to understand that right now, there is a whole nother, there's an infinite number of standard models of particles that don't interact with our standard model. That's why we say principles and protocols. We all know what the principles are. The protocols are kind of more like the laws of physics. So we have a certain set of principles and protocols. Those protocols allow us to interact with other ESAs, other self-awareness that has similar rule sets, similar protocols. But there's going to be plenty that don't. And that's what Lex Fridman is getting into. And that's kind of what Vince pointed out. Great point, Vince.
Imagine that dolphins are intelligent, but never invent space travel because they live in the ocean and they don't have thumbs, right? So they never invent technology. They never invent smelting. Maybe the universe is full of intelligent species that just don't make technology, right? That's compatible with the data, I think. And I think maybe what you're pointing at is even more out there versions of intelligence, intelligence in intermolecular clouds, or on the surface of a neutron star, or in between the galaxies in giant things where the equivalent of a heartbeat is 100 million years. Right. On the one hand, yes, we should be very open-minded about those things. On the other hand, we all of us share the same laws of physics. There might be something about the laws of physics, even though we don't currently know exactly what that thing would be, that makes meters and years the right length and time scales for intelligent life. Maybe not. But, we're made of atoms. Atoms have a certain size. We orbit stars. Stars have a certain lifetime. It's not impossible to me that there's a sweet spot for intelligent life that we find ourselves in. So I'm open-minded in either way. I'm open-minded either being humble and there's all sorts of different kinds of life, or no, there's a reason we just don't know it yet why life like ours is the kind of life that's out there.
Yeah, I'm of two minds too, but I often wonder if our brains is just designed to, quite obviously, to operate and see the world in these time scales, and we're almost blind, and the tools we've created for detecting things are blind to the kind of observation needed to see intelligent life at other scales.
Well, I'm totally open to that, but so here's another argument I would make. We have looked for intelligent life, but we've looked for it in the dumbest way we can, right? By turning radio telescopes to the sky. Yeah. And why in the world would a super advanced civilization randomly beam out radio signals wastefully?
Sorry, guys. Alien T, if you're still here, I don't know. We're going to watch some videos. We're going to kick it depending on how long I'll be live. Another hour and a half, 2 hours. I don't know. It just depends on how the live's going and if people are digging it. So make sure you're liking it and sharing it with other people. Let's get this thing going. Let's have a good conversation. Because I want to get some recommendations from you guys as well. We'll have to build a list. Maybe in the Discord would be a good place. I think we have TikTok. We have a channel that's like TikTok live topics. And what you could do is put a video in there. And I think as long as it's less than, 30 minutes, I think would be about as long as we'd want a video to be. So we can talk and watch the video, right? So I think that's probably the sweet spot. So yeah, that would be my guess. You know, get over to the Discord and put topics in there if there's videos, and they could be really anything, you know, but just be ready for, you know, us to have a conversation about it. So, you know, no, you have to be ready to have a conversation about it if you want us to watch it. Okay, cool, awesome. And then there was another thing about Chris said something about the Goldilocks zone and harboring life and our life. And so this is why, like, if we go to Mars, there'll have to be some terraforming, because we need it to simulate the Goldilocks zone for us. But that's for our, you know, life doesn't only thrive under certain conditions, just the life that's like ours. Right? We know that if it's too cold, there's not going to be life. We know that if the surface of the planet is made of, like, you know, like liquid nitrogen, humans probably aren't there. But it doesn't mean that there isn't some form of life. Now, carbon-based life forms, and, you know, there's a reason why carbon is more abundant, you know, why carbon-based life form is better than like silica-based life form. And I think it's because silica oxide is like sand. It, like, to breathe would create this like sand substance, and for us it creates carbon dioxide versus silica dioxide, I think, or silicon oxide, something like that, right? When you take in the oxygen. Sorry, I don't remember the exacts. So yes, but it doesn't mean that there aren't life forms out there that are silica based, that if they use oxygen, they're creating sand out of their pores, right? There's microsands. They're brushing sand off or whatever. I mean, to limit it down and just say, oh, well, the way we've evolved is the only way to evolve is a silly argument. You need to look at the constraints of each element that could support life and understand what its Goldilocks zone is.
Flee in all directions into the universe. That just doesn't make any sense, especially because in order to think that you would actually contact another civilization, you would have to do it forever. You'd have to keep doing it for millions of years. That sounds like a waste of resources. If you thought that there were other solar systems with planets around them where maybe intelligent life didn't yet exist but might someday, you wouldn't try to talk to it with radio waves. You would send a spacecraft out there and you would park it around there, and it would be like, from our point of view, it'd be like 2001, where there's an monolith. So there could be an artifact. In fact, the other way works also, right? There could be artifacts in our solar system that are have been put there by other technologically advanced civilizations, and that's how we will eventually contact them. We just haven't explored the solar system well enough yet to find them. The reason why we don't think about that is because we're young and impatient, right? Like, it would take more than my lifetime to actually send something to another star system and wait for it and then come back. So, but if we start thinking on hundreds of thousands of...
So what he's talking about here, in case you guys are not sure why it takes forever to communicate, because here on Earth we can call somebody and communicate right away, because this information that we're sending out to these other life forms doesn't travel faster than the speed of light. That's the absolute fastest that it can travel. So, you know, we have this speed limit of information. So because and that's really what you can't travel faster than the speed of light. What that really boils down to, because there's tricks and ways to make things move faster than the speed of light. It's the information. The information cannot travel faster than the speed of light. That's where the law comes into place. So what he's saying is, okay, if you have this thing that is, let's say, and it's not hard to say, okay, 70 light years away. And a light year is how far light travels in a year. And let's say we're moving at half the speed of light. Our information's moving at half the speed of light. It's going to take 140 years just for the information to get there. Then you got to wait for the response. And depending on their technology, let's say it's similar, it's another 140 years. So you're looking at 280 years. And your broadcast, now you can broadcast radio waves radially, so they'll broadcast out everywhere, but it doesn't mean that as it's traveling through space, it's still going to be affected by gravitational pulls and get distorted. So now you have informational integrity. So you've got to get this information around these massive planets and somehow keep the informational wave packets the same size with the same information. So yes, to me, that's more realistic. that although and then they have to have technology that receives radio waves, right? That they're not using some other technology. Sean Carroll's assuming that the problem with Sean Carroll's answers is he's trying to show how we can't communicate, not that life doesn't exist. He's just giving examples about communication. Lex Fridman's question was, do you think life exists? Not, can we communicate with it,
Thousands of years or million-year timescales, that's clearly the right thing to do.
Are you excited by the thing that Elon Musk is doing with SpaceX in general? But the idea of space exploration, even though your species is young and impatient?
Yeah. No, I do think that space travel is crucially important long term, even to other star systems. And I think that many people overestimate the difficulty because they say, look, if you travel 1% the speed of light to another star system, we'll be dead before we get there, right? And I think that it's much easier. And therefore, when they write their science fiction stories, they imagine we could go faster than the speed of light because otherwise they're too impatient, right? We're not going to go faster than the speed of light, but we could easily imagine that the human lifespan gets extended to thousands of years. And once you do that, then the stars are much closer, effectively, right? And what's a 100-year trip, right? So I think that that's going to be the future, the far future, not my lifetime once again, but baby steps.
Unless your lifetime gets extended.
Well, it's in a race against time, right?
Yeah.
A friend of mine who actually thinks about these things said, you and I are going to die, but I don't know about our grandchildren. I don't know. Predicting the future is hard, but that's at least a plausible scenario. And so, yeah, no, I think that as we discussed.
Well, and like he said, the speed of light is 300,000-ish meters per second, 300,000 meters per second. So about 186,000 miles per hour. Miles per second. So let's just stick with meters. So 300,000 meters per second, right? So if we were to say that we were to move at half the speed of light, we would be moving at 150,000 meters per second. Right? So that's why he's using numbers like, 1% the speed of light, right? Because that's like 3,000 meters per second. That's, when we drive, right, that is extremely fast. That's extremely fast. Us getting to 1% the speed of light is extremely fast. So we would need to find a way to move even faster. Now, luckily, moving through space, you don't have gravity pulling you back. So as long as you have the fuel to accelerate, you will continue at that velocity unless you start to hit gravitational fields of other planets, which you could actually use to your advantage to slingshot you forward to propel you. So, it is this monstrous task that we're looking at to try to, and I think that's built into, I think there's a reason for that. It's like you must have technology that reaches a certain level of sophistication before you can even consider traveling somewhere else, right? Before you can even consider traveling somewhere else. And that's because that sophistication comes with time, and it comes with, they know, right? I feel like it's just built into the matrix. It's built into the protocols. You wouldn't want somebody that just invented nuclear weapons to be able to travel interstellarly. That's like it's not something that you would want, right? Because they might travel. They still kind of live they're still primitive. We're still primitive. We are still primitive until our technology reaches a certain standard, which means that we understand the universe in a way that is very, very sophisticated. We're not going anywhere. People might come here. You might have life forms here, which I think we do have life forms here that might, facilitate certain things. And maybe there's contracts and, who knows what's happening there. There's a million different things that we could say. But what we can say for sure is that our technology has not reached that yet.
We discussed earlier, there are threats to the Earth, known and unknown, right? Having spread humanity and biology elsewhere is a really important long-term goal.
What kind of questions can science not currently answer but might soon? When you think about the problems and the mysteries before us that may be within reach of science.
I think an obvious one is the origin of life. We don't know how that happened. There's a difficulty in knowing how it happened historically, actually, literally on Earth.
Sorry, real quick. There was a good question in the chat, and there's a lot of good questions. I just don't want to pause for every question. Sorry, guys. Luminal Taurus said, "Is it true that time travel, if possible, would make it easier to bypass that?" So, not necessarily time traveling. It would need to be traveling through space time. So, you would need to time travel if we're just talking about the time aspect. If you think of like time and space, like a Minkowski diagram, where you've got time and space, just being able to travel through time in the same, right? Essentially being able to go this way doesn't necessarily help because you're in the same space. So you would need to be able to travel through time and space. Sorry, I'm doing like an XY diagram here on my fingers. So yeah, I mean, time necessarily isn't going to help unless you're like, oh, well, we could time travel to the future and get to a place where technology allows us to travel through space. You know, that's a possibility. But and time travel to the future is actually something that we already essentially know how to do. Right, with different gravitational forces. You guys have all seen, I'm sure, Interstellar, and Interstellar is a great movie if you haven't seen it. But they do a really good job representing time travel. Like when he's on that, when they go to that planet and he comes back, and he was only down there for like 30 seconds, but like I forget how long passed, like a decade or something passed. Now, would it be that drastic? No, because what they didn't consider was the gradient of the gradient of the gravitational effect. So even though you have something on the surface, yes, gravity's stronger there, but it's going to be stronger up as well, right? It's going to be stronger the further away you get, and it's going to fall off as 1 over r squared. So it's going to fall off the distance, right? The radius squared, 1 over the radius squared. That's the gravitational effect falling off and being, it gets smaller the further you get away. So it wouldn't have been that drastic because the ship wasn't that far away, but you know, we would be able to utilize things like moving faster or going to a place that has a higher gravitational field where our body and our technology can survive. That's the other thing. It's like maybe his suit was protecting him, but for his body would have been crushed, right? If the gravitational force was that strong on that planet to where like decades had passed versus seconds, you know, he never would have left that planet, right? That just wouldn't have happened. Our body's not built for that kind of gravitational pull.
But starting life from non-life is something I kind of think we're close to, right? We're really.
You really think so? How difficult is it to start life?
I do. Well, I've talked to people, including on the podcast, about this. You know, life requires 3 things. Life as we know it. So there's a difference between life, which who knows what it is, and life as we know it, which we can talk about with some intelligence. So life as we know it requires compartmentalization. You need like a little membrane around your cell. Metabolism, you need to take in food and eat it and let that make you do things. And then replication. Okay, so you need to have some information about who you are that you pass down to future generations. In the lab, compartmentalization seems pretty easy, not hard to make lipid bilayers that come into little cellular walls pretty easily. Metabolism and replication are hard, but replication we're close to. People have made RNA-like molecules in the lab that I think the state of the art is they're not able to make one molecule that reproduces itself, but they're able to make 2 molecules that reproduce each other.
Yeah.
So that's okay. That's pretty close. Yep. Metabolism is harder, believe it or not, even though it's sort of the most obvious thing, but you want some sort of controlled metabolism, and the actual cellular machinery in our bodies is quite complicated. Mm-hmm. It's hard to see it just popping into existence all by itself. It probably took a while, but we're making progress. And in fact, I don't think we're spending nearly enough money on it. If I were the NSF, I would flood this area with money because it would change our view of the world if we could actually make life in the lab and understand how it was made originally here on Earth.
And I'm sure it'd have some ripple effects that help cure diseases and so on. I mean, just that understanding.
Right. So synthetic biology is a wonderful big frontier where we're making cells. Right now, the best way to do that is to borrow heavily from existing biology, right? Craig Ventnor, several years ago, created an artificial cell, but it was a tremendous accomplishment, but all he did was take out the DNA from a cell and put in entirely new DNA and let it boot up and go.
What about the leap to creating intelligent life on Earth?
Yeah.
However, again, we define intelligence, of course, but let's just even say Homo sapiens, the modern intelligence in our human brain. Do you have a sense of what's involved in that leap and how big of a leap that is?
So AI would count in this, or you really want life? You want really a organism in some sense?
AI would count, I think.
Okay.
Yeah. Of course, AI would count. But
Well, let's say artificial consciousness, right? So I do not think we are on the threshold of creating artificial consciousness. I think it's possible. I'm not, again, very educated about how close we are, but my impression is not that we're really close because we understand how little we understand of consciousness and what it is. So if we don't have any idea what it is, it's hard to imagine we're on the threshold of making it ourselves. But it's doable. It's possible. I don't see any obstacles in principle. So yeah, I would hold out some interest in that happening eventually.
I think in general, consciousness, I think we'll be just surprised how easy consciousness is once we create intelligence.
Yeah.
I think consciousness is a thing that that's just something we all fake.
Well, good. No, actually, I like this idea that in fact consciousness is way less mysterious than we think.
Yeah.
Yeah, I think Lex is actually making a great point here because he's very human centric. I'm realizing Sean Carroll has a very human centric and linear, like Vince was saying, linear point of view, which is a great point. I mean, as a scientist, it's fine, but his human centric. Now, yes, I do like the idea, what blocks us a lot of the time in the lab or in science in general is kind of ideologies of whatever faith. Usually it's Christian because in the Western world, it's Christianity with science, which is blocking us from certain breakthroughs because like imagine if scientists weren't able to, look into a cadaver because the body was holy, even whether there was someone in it or not. And we would have no idea, like modern medicine and modern science would be, would be lacking if we weren't able to do that. So it's very similar here. It's like, we are starting to break through some of those thresholds, but that's what they were talking about earlier. But I think that this idea that consciousness, where does it start and where does it end? Humans? Just humans. What about a prefrontal cortex? That's where it starts. What about mammals? Is it mammals or is it just humans? Okay, well if it's just humans, well what if when another life form comes along, or if we can imagine another life form with more intelligibility, a larger brain, they understand the universe much better than we do, and they come here and they say, humans aren't conscious. They're not conscious. They don't have the prefrontal cortex like we do. They just have the prefrontal cortex or whatever, right? It's ridiculous to start to say that there is some cutoff point. Now there's a threshold where certain attributes might manifest, but to say that consciousness is something that, in my mind, machine learning algorithms, we're already there. Machine learning algorithms are they are as intelligent as some life that already exists on Earth. And yes, it's not human, but it's not to say that it isn't intelligible.
Because we're all at every time, at every moment, less conscious than we think we are, right? We can fool things. And I think that plus the idea.
Oh, real quick. Yes, I've seen ethic concerns with artificial brains. Here, let's think about this. I think one thing we need to think about, because I had this realization and it scared me. Yes, because there's this idea of growing these microbrains, or like these chunks of neurons essentially, and then having them, essentially pulse based off of dopamine or whatever, right? Whatever is going to make them go. But then those little brains would be going through a sense of like a withdrawal, right? It would be going through a sense of, lacking the efficient thing, like the homeostasis. We would be taking advantage of the fact that it exists in some homeostasis, and we would push it out of that homeostasis, and then it would need to come back to homeostasis. So that's where because imagine if you were like this thing that like got these surges of dopamine, but then you went through withdrawal, right? You went through like this crazy withdrawal and it was terrible. and then you got the boost again, and then you went through this crazy withdrawal. So, you need I don't know, right? You need more of a vehicle. You need more perceptions to be able to experience it. It's just an idea. It's just a thought experiment that I had. That's like, well, what if that's what we are? What if us experiencing this dopamine is just some larger beings getting a kick out of something, using us to its advantage. And then when we, our physical bodies have to experience the ramification, but it doesn't. So yes, there is ethical concerns around, essentially taking advantage of artificial brains.
The idea that you not only have artificial intelligent systems, but you put them in a body, right? Give them a robot body. That will help the faking a lot.
Yeah, I think creating consciousness in artificial consciousness is as simple as asking a Roomba to say I'm conscious and refusing to be talked out of it.
Could be. It could be. Yeah.
And I'm almost being silly, but that's what we do. That's what we do with each other. This the kind of that consciousness is also a social construct, and a lot of our ideas of intelligence is a social construct. And so, reaching that bar involves something that's beyond. Doesn't necessarily involve the fundamental understanding of how you go from electrons to neurons to cognition.
No, actually, I think that is an extremely good point. And in fact, what it suggests is, you referred to Kate Darling, who I had on the podcast, and who does these experiments with very simple robots, but they look like animals, and they can look like they're experiencing pain, and we human beings react very negatively to these little robots looking like they're experiencing pain. And what you want to say is, but they're just robots. It's not really pain, right? It's just some electrons going around. But then you realize, you and I are just electrons going around, and that's what pain is also. And so what I would have an easy time imagining is that there is a spectrum between these simple little robots that Kate works with and a human being, where there are things that sort of by some strict definition, Turing test level thing, are not conscious, but nevertheless walk and talk like they're conscious. And it could be that the future is, Siri is close, right? And so it might be the future has a lot more agents like that. And in fact, rather than someday going, aha, we have consciousness, we'll just creep up on it with more and more accurate reflections of what we expect.
And in the future, maybe the present, for example, we haven't met before, and you're basically assuming that I'm human. It's
I give it a high probability
at this time, because but in the future there might be question marks around that, right?
Yeah, no, absolutely. Certainly videos are almost to the point where you shouldn't trust them already. Photos you can't trust, right? Videos is easier to trust, but we're getting worse at, we're getting better at faking them,
yeah,
right?
We're getting better at faking.
So physical embodied people, what's so hard about faking that? So this is very depressing, this conversation we're having right now. So
no, to me it's exciting.
To me, you're doing it, so it's exciting to you, but it's a sobering thought. We're very bad, right, at imagining what the next 50 years are going to be like when we're in the middle of a phase transition as we are right now.
Yeah, and in general, I'm not blind to all the threats.
Yeah.
I am excited by the power of technology to protect us against the threats as they evolve. I'm not as much as Steven Pinker optimistic about the world, but it never.
So he's making a good point here, because what makes me a human? If I have a pig heart, or I needed a transplant from whatever, am I still a human? Okay, well, what if it's synthetic? What if I have a prosthetic limb? Am I still human? What if I have a prosthetic heart? What if we get to the point of making prosthetic hearts? What if I have an eye that allows me to see infrared? Right? What if I'm connected with Neuralink with 15 other people, and we all have different disciplines, and we all can download information at the same time, and we're all learning through 15 different lenses at once? Am I still human? Where does it end and where does it begin? What if I wanted to implant something that makes me fly? What if I changed my arms into wings? Because we're going to get there with Michael Levin's work, and we're going to watch some Michael Levin stuff too. and we're going to watch some John Vervaeke stuff, and we're going to watch some Stephen Wolfram stuff, and Neil Seth, all the stuff that gave us inspiration for the books. We're just going to watch and get comfortable with their concepts. But Michael Levin talks about the bioelectric field. So when we start manipulating the bioelectric field and creating, and it's not even now it's not even synthetic. It is my bioelectric field that I'm manipulating to be able to do these things. Am I still human? That's like Lex is making a great argument here. Let's see. And let's take some time to look at some of these questions. I have always pondered on how many species evolved in space and not on a planet. Well, we have to be, yes, of course. I mean, the conditions of what is needed so space, you're going to have less fuel. So what he was talking about was compartmentalization, some sort of metabolism, and some ability to reproduce. I think in space, you're going to have trouble with that second one, because what gravity does is it concentrates energy. It centralizes, it pulls different resources into one spot locally. So, life as we know it, I'm not saying it doesn't happen, but, you would need all these things to start building these complex organisms, and then it would need the materials to reproduce. Yeah, Sarah Lynn, I guess I didn't know what you meant by it. I was saying, like, what is it? Because you're saying it. Well, fake means genuine. Certainly, if it exists, it would be genuine first. I don't know what it is. Different from other things in existence. Be genuine, just different from other things in existence. Yes. But I need to know what it is. Trent, have you explored the work of Peter Singer and personhood? No, I haven't. But if you want to find, so what I was saying is if there's a clip you want us to watch, if you have like a Peter Singer clip, now it needs to be less than 30 minutes, I would say somewhere. 30 minutes is probably the max. Like this guy is probably the max, because I'd like to get like 2 done in a live. But if you want to go to the Discord and put a screenshot or a link to it in the TikTok live topics channel, then we can watch it. But I'm not familiar, and I've never seen this either. What I want to do is just watch videos that I haven't seen with everybody, and then we'll just talk about it. They already have TAH. I'm not sure what TAH is. Does the transplant change the genetics of the system? Exactly. No, I mean, it would locally a transplant, right? The genetics of that heart would now be of a pig heart or whatever, right? It would locally change the genetics. It would also, you would think, change the bioelectric field, because now the bioelectric field is different. You have different atoms there, and that could be part of the reason it gets rejected. Anything that was created. Oh, it is anything that was created, like as far as artificial life. Yeah, total. Oh yeah, artificial heart. Okay. Yeah, I see what you're saying. I think, Sarah, I'm trying to remember what the original question was. Let me see if I can find it. If it exists, is it actually fake? I mean, I guess, yeah, so you're talking about fake and genuine, and, to me, emergent data structures are just emergent data structures. They are real at that level, right? They are real at the level at which they emerge. They might be made of something more fundamental, but they are real at which the level that they emerged. It's an algorithm. If it's an algorithm, it's an algorithm, and that's what it is. It's a set of rules working together. Personhood, philosophy 101, person versus human versus consciousness. Okay, cool. Yes, we can definitely watch that. I missed that one. I'm glad I scrolled back. And this stuff is why we need philosophy, right? Yes, that's exactly what I said earlier. This fringe physics, and that's what I'm trying to show. That's what I want to show the community. That's what I want to show the larger, TikTok world, is that, and people in general, is that this is why we need philosophy, because in physics, at the edge of physics is always philosophy. Metaphysics, or metaphysics, whatever you want to call it, that's at the edge. Now, you can take it further and take it more abstract, and not every idea is correct. And that's the other thing we need to remember. Just because we can philosophize about it on a metaphysical level doesn't mean we'll be able to pull it into our tangible reality. Doesn't mean that it doesn't exist somewhere, because if you've thought about it, it probably exists somewhere. But just, I'm talking about here locally. But yes, this is why we need philosophy. So would it be a percentage thing? It's dangerous territory if you think about it. Exactly. Well, yeah. When am I no longer human? Exactly. And does it have to do with the brain and what I think and my capacity? Are we going to localize it to that? Because then if we start growing artificial brains, is that a human? If I can clone my brain, is that 2 humans? Yes, yeah, like how much of an individual system is of human genetics. But then again, that's like, so Trinity, the problem with that argument, and I'm just calling it out because that's what I'm doing right now. I don't think you can I don't think there's a spectrum. I don't think you can have a cutoff point where it's like, meh, that's human and that's not. I just don't think you can do that. I think if you're going to call it something, it is that, and everything about it is that. No matter what, that thing's human. And then what does it mean to be human? Well, what does it mean to be conscious? And then you start jumping into these other questions, these more philosophical questions that we could all, I'm sure that we'll all answer together one day. But for me, it's like, yeah, it's a dangerous point, because when you get people, it's only dangerous to people like Sean Carroll, because it destroys their arguments. Because Lex is essentially being very nice. And Lex Fridman, I think, went to like MIT, and he was like an AI guy. He was like a machine learning computer scientist guy before he got famous on YouTube. So that's why he has a similar approach that I do. Even though I'm the physicist, so you would think I'd be closer to Sean Carroll, but I'm not at all.
But in everything I've seen, all of the brilliant people in the world that I've met are good people. So the army of the good in terms of the development of technology is large.
Okay. You're way more optimistic than I am. I think that goodness and badness are equally distributed among intelligent and unintelligent people. I don't see much of a correlation there.
Interesting. Neither of us have proof.
Yeah, exactly. Again, the opinions are free, right?
Nor definitions of good and evil. We come without definitions or without data.
Yeah.
Opinions. So what kind of questions can science not currently answer, may never be able to answer in your view?
Well, the obvious one is, what is good and bad? What is right and wrong? I think that there are questions that, science tells us what happens, what the world is.
So I think that he's wrong there again. Yes, what is good and bad in those terms, but if you think of things as suboptimal and optimal, and again, everything is optimal in a sense because it's all leading to something, but so there's that little bit of like a fringe, like, oh, but it's all leading somewhere. So, right, the vile person will be the sage. It's like, yeah, that's true, but it doesn't mean that you can't look at something and see when something's operating efficiently, like it's efficiently using its resources, and when it isn't. And to me, it's that easy. You can't really say that it's that easy. If it's good, again, it goes back to the argument of, well, are we going to start talking about emotions and, oh, well, the guy who lost his goat, which was bad, but then the goat was his long lost son saw the goat and brought the goat back to, brought the back to his father, and everybody, oh, that's good. Oh, but then because the son was back, he broke his leg. Oh, that's bad. And because, that's not even looking, in my mind, that's not even looking at optimal and suboptimal. It's not even looking in the right place. So he has a point, because again, you could say all things end up leading to the sum total events is the sum total of events. So if that's his argument, but I don't think that's his argument. He's talking more about ethics, I think, and morale, but let's see.
The world is and what it does. It doesn't say what the world should do or what we should do, because we're part of the world. But we are part of the world, and we have the ability to feel like something's right, something's wrong. And to make a very long story very short, I think that the idea of moral philosophy is systematizing our intuitions of what is right and what is wrong. And science might be able to predict ahead of time what we will do, but it won't ever be able to judge whether we should have done it or not.
So, you're kind of unique in terms of scientists. It doesn't have to do with podcasts, but even just reaching out, I think you referred to as sort of doing interdisciplinary science. So you reach out and talk to people that are outside of your discipline, which I always hope that's what science was for. In fact, I was a little disillusioned when I realized that academia is very siloed.
Yeah.
And so the question is, at your own level, how do you prepare for these conversations? How do you think about these conversations? How do you open your mind enough to have these conversations? And it may be a little bit broader. How can you advise other scientists to have these kinds of conversations? Not at the podcast. The fact that you're doing a podcast is awesome. Other people get to hear them.
Yeah.
But it's also good to have it without mics in general.
it's a good question, but a tough one to answer. I think about, a guy I know is a personal trainer, and he was asked on a podcast, how do we, psych ourselves up to do a workout? How do we make that discipline to go and work out? And he's like, why are you asking me? Like, I can't stop working out. Like, I don't need to psych myself up. So, and likewise, you asked me, like, how do you get to like have interdisciplinary conversations and all sorts of different things with all sorts of different people? I'm like, that's what makes me go, right? Like I couldn't stop doing that. I did that long before any of them were.
Well, the problem with what he's saying is Huberman, if you guys are familiar with Dr. Huberman, we'll probably watch some of his stuff too. Andrew Huberman, he talks about this. He talks about limbic friction and what limbic friction is and how to how to remove some of that limbic friction. It's essentially, there's multiple ways to do it. You can stack dopamine, right? You can stack dopamine. You can make things that are detrimental to you harder to reach, right? Essentially moving, if you have a problem with the TV, every time you're done with the TV, unplug it and put it in the closet. And that means you have to go get it. And is it worth it? Is it worth it for that short hit of dopamine? So there's multiple ways. And then setting habits is another way, which helps remove some of that limbic friction. So he's kind of talking about more of like, oh, well, there's no way to program yourself. I hated math when I was younger. It was hard. But the more I did math and the more I understood the concepts and the more time that I spent on it, the more I started to enjoy it. The more that my brain started to get the dopamine hits when I solved that difficult problem, when I solved that difficult puzzle. So to say, oh, well, it just makes me tick, other people can't have those conversations, is just ridiculous. Maybe people don't want to have it in a dry academic sense. Maybe people want to have it through storytelling. Maybe people want to have it, over a beer or whatever. A lot of physicists drink. So, let's see if he actually gets into that.
Them were recorded. In fact, a lot of the motivation for starting recording it was making sure I would read all these books that I had purchased, right? Like I had all these books I wanted to read, not enough time to read them. And now if I have the motivation, because I'm going to, interview Pat Churchland, I'm going to finally read her book, And it's absolutely true that academia is extraordinarily siloed, right? We don't talk to people. We rarely do. And in fact, when we do, it's punished. Right. The people who do it successfully generally first became very successful within their little siloed discipline, and only then did they start expanding out. If you're a young person, I have graduate students, and I try to be very, very candid with them about this, that it's, most graduate students do not become faculty members, right? It's a tough road. And so live the life you want to live, but do it with your eyes open about what it does to your job chances. And the more broad you are and the less time you spend hyper specializing in your field, the lower your job chances are. That's just an academic reality. It's terrible. I don't like it, but it's a reality. And for some people, that's fine. Like there's plenty of people who are wonderful scientists who have zero interest in branching out and talking to anyone outside their field. But it is disillusioning to me. Some of the romantic notion I had of the intellectual academic life is belied by the reality of it. The idea that we should reach out beyond our discipline, and that is a positive good, is just...
Yeah, I had a very similar experience here with going to school and asking all the questions and trying to understand the history and the philosophy behind special relativity and general relativity, and wanting to know how Albert Einstein ticked, and not just him, but the wave equation, the Dirac equation, where the Copenhagen interpretation came from, what was the arguments, and it's not, for me, even just for me at all, talking about metaphysics, right? As someone who has their degree in physics, instantly alienated me in school, even in school when I would try to do it with other students, right? And if it ever got brought up and a teacher was around, it was even worse. It's like, oh, you don't really care about scientific rigor and all you care about is fanciful things. It's a terrible, so ostracize, right? You ostracize yourself. You got someone like Stephen Wolfram, who is, at 20 years old was creating a Wolfram Alpha and solving, and just a brilliant mind, proved himself. Like he said, a lot of times you have to prove yourself before you can go into these other disciplines or into fringe science. And he still gets, now he gets ridiculed and gets laughed at for some of his theories with the Rulliad and the hypergraph and some of these amazing ideas that this brilliant individual has. He gets ridiculed. So it is a scary, it's scary in the sense that humanity is where it's at, that it can't allow the brain any flexibility, especially in academia. It's like it's a club and either you're in it or you're not. And either, like he said, hyper focused to where you're only, right? Some of the highest paid doctors, and I'd like to watch this too, but it's very long, where this lady, she went in and she was like working on the inner ear. And she's working on like one little space that's like a cubic centimeter inside of the ear, making, $500,000 a year. And that's all they focus on is that little spot inside of the ear. And if she was to want to go holistic, which is what she wanted to with like food and diet, she got ostracized and she ended up having to quit her job. So
is just so rare in universities that it may as well not exist at all.